All right, welcome back, Focus Learners, to another explainer. I am absolutely thrilled to have you here today because we are stepping into the ultimate arena of Cambridge mathematics. Now, whether you're tackling syllabus code 0580, 0606, 4024, 4037, or even 4040, the reality of the situation is exactly the same. Getting a top-tier grade, it isn't just about crunching numbers or memorizing formulas. It is really about orchestrating your arguments. I want you to think of yourself as a master symphony conductor for a moment. Write every single line of your working out, every defined variable, every logical deduction you make, they are all distinct instruments in your orchestra, and they absolutely need to play in perfect harmony to get those top marks. Okay, so let's dive right into this, because today we are going to completely transform the way you approach some of the absolute most intimidating algebra questions on your paper.
Now, if your heart rate just spiked a little bit looking at these, honestly, you are not alone. How on earth do you solve 3e to the power of x equals 12 minus 5e to the power of negative x without totally panicking? Or, hey, what about x to the power of 4/3 plus x to the power of 2/3 minus 12 equals 0? Or even worse, 2 times the natural log of 5x all squared plus the natural log of 5x minus 6 equals 0. These complex substitution equations are pulled directly from the 0606 additional mathematics syllabus. And let's be real, they look absolutely terrifying. They look like they're written in completely different languages. You've got exponentials, fractional indices, natural logarithms, the whole shebang. But what if I told you they're all actually wearing the exact same disguise? Underneath all that complex formatting, they are literally all just hidden quadratics waiting for you to unmask them.
And you really need to unmask them, because here is the hard truth of the matter. 15%. That's right, these specific types of complex substitution examples, where you have to transform an intimidating, messy equation into a nice, solvable quadratic, they account for a massive 15% of the total marks in the additional mathematics examination. Just let that sink in for a second. 15%. Mastering this single conceptual framework can single-handedly elevate your final score by over an entire grade boundary. You literally cannot afford to leave these blank in the exam hall, and you certainly cannot afford to just guess your way through them, hoping for the best.
So here is our highly logical blueprint for today's explainer to make sure you get those marks. First, we'll look at the 15% challenge. Second, we'll break down the method mark strategy. Third, we'll give you a procedural framework. Fourth, we'll run a quick interactive workshop. And finally, we'll cover some critical examiner warnings.
All right, Section 1, the 15% challenge. Let's look at exactly how marks are being lost. Let me introduce you to two hypothetical students pulled straight from our Cambridge past paper files. We've got Alex and we've got Sam. They both face the exact same exponential equation in their exam, but they lost marks for entirely different reasons. So Alex's approach is just a total mess of raw math facts. Alex immediately tries to multiply things in his head, scribbles down overlapping exponents everywhere, and basically overloads the page with raw numbers. There's absolutely no structural analysis, no defined variables, and zero logical flow. It's just chaos. Then on the flip side, we have Sam. Sam rushes. Sam completely ignores the command word requirements. Sam might actually figure out what x roughly is using a calculator, but totally skips the algebraic proof steps required to get there. Without a structured way to solve complex mathematical texts and data, both Alex and Sam inevitably lose the majority of the marks. You see, they're just trying to find the final number, which completely misses the entire point of the exam.
Moving on to Section 2, the method mark strategy. This is the insider secret.
We are shifting our focus right now from merely finding that final correct number to mastering the step-by-step process. The method mark strategy is essentially an assessment approach where examiners award marks for logical, structured reasoning and your analytical process, rather than just that final numerical answer at the bottom of the page. Think about it. If you clearly define a substitution variable, boom, that is a mark. If you correctly rearrange the messy equation into a standard quadratic form, that is a mark. If you show your exact factorization process, that's another mark. The final answer is often only worth one single mark out of a 5-mark question. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Consider this direct quote from an actual Cambridge senior examiner. The assessment framework prioritizes analytical depth over superficial breadth. So what does that actually mean for you sitting in the exam hall? It means examiners do not just want to see that you know how to punch numbers into a calculator. These assessment objectives are targeting distinct cognitive domains, your knowledge, your application, and your analysis. The whole theoretical architecture of these substitution problems rests on your ability to show cross-topic connections. For example, explicitly connecting your knowledge of indices directly to your knowledge of quadratics. Showing that analytical depth, step by step, is exactly what achieves significantly higher marks.
Okay, Section 3, the procedural framework. Let's look at the actual technical methodology here.
So how do we guarantee that we actually hit those specific cognitive domains? Well, here is the exact 5-step procedural framework you are going to use from now on. Step 1, deconstruct the question. For an equation like 3e to the power of x equals 12 minus 5e to the power of negative x, you look at it and identify the negative exponent as the core problem. Step 2, extract relevant data. You multiply the entire equation by e to the power of x to remove that awkward fraction. That gives you 3e to the power of 2x equals 12e to the power of x minus 5. Step 3, select your analytical framework. Guys, this is the golden step. You state explicitly on the paper, let u equal e to the power of x. You have now beautifully transformed the problem into 3u squared minus 12u plus 5 equals 0. Step 4, execute with clear notation. Simply solve that quadratic for u using the quadratic formula or factorization. And finally, step 5, present with correct terminology. Link your u value back to e to the power of x and use natural logarithms to solve for x. It is a flawless, mechanical process every single time.
To really lock this in, we use a pretty powerful memory hack. I want you to think of it as a visual story. Imagine you arrive at a locked door. That represents identifying the given info. You search and find the key components. That's breaking the equation into logical steps. You physically turn the key in the lock. That's solving the quadratic systematically. You open the door and look inside the room. That's checking your answers for reasonableness. And finally, you confidently walk through the door, making your final justified presentation. Encoding these complex mathematical concepts as a sequential physical story ensures they are easily recalled even when you're under extreme exam pressure.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, our interactive workshop. Let's put method over magic.
We are going to apply the structured approach right now to some live data extraction. First up is our 60-second data scan challenge. In Cambridge Mathematics, your data interpretation skills are absolutely critical. You must be able to look at complex formats, like a heavily structured table or a weird sequence of terms, and immediately extract the data, interpret the relationships, and evaluate the evidence quality. For example, if you see x to the power of 4/3 in one part of an equation and x to the power of 2/3 in another, your brain needs to instantly scan that relationship and recognize that 4/3 is exactly double 2/3, right? That 2-to-1 ratio is your practical action trigger. It screams, use a quadratic substitution. Always, always scan for that hidden relationship first.
Now let's move to the Find the Flaw in Speed Writing Challenge. And honestly, this brilliantly illustrates how we can use standard essay writing tricks in advanced math. So you have a flawed mathematical explanation, just a messy jumble of algebra rushing to the final answer. But instead, we are going to apply the perfect Peel framework to 3e to the power of x equals 12 minus 5e to the power of negative x. Yes, you heard me right, the Peel framework in math. Point, you clearly state that the equation can be rearranged into a hidden quadratic. Evidence, you explicitly write let u equal e to the power of x. Explanation, you show the systematic execution of the quadratic formula on 3u squared minus 12u plus 5 equals 0. And link, you link your final values of u back to x using natural logarithms, ensuring you evaluate the evidence quality. What do I mean by that? I mean rejecting any negative values for u, because an exponential function like e to the power of x cannot be negative. It is perfectly structured and it guarantees every single method mark.
Section 5, Critical Examiner Warnings. Let's look at some principal insights. We are now moving into our final system safeguard phase. The principal examiners consistently report these top 3 mistakes year after year. Number 1, confusing cause and effect. In our logarithmic example earlier, 2 times the natural log of 5x all squared. Students very often incorrectly apply power laws. They confuse the square of the whole logarithm with the logarithm of a squared term. Huge mistake. Number 2, forgetting format and presentation. You absolutely must show clear steps. An answer alone scores 0 marks if the command word is show that. Number 3, answers not specific to the given context. Look, if you solve for u and get a negative number, but your substitution was u equals e to the power of x, you must explicitly state that e to the power of x is greater than 0, so there's no real solution for that specific branch. Candidates severely lose marks by not evaluating their final answers against the original mathematical context.
The crucial takeaway here is implementing a defensive strategy for your exams. Contrast the flawed rushed approach with a top-grade approach. Top candidates don't just do math, they communicate it. They clearly define their terms, writing let y equal the natural log of 5x. They use proper headings and crystal clear annotation. They use comparative connectives, and in math, this means using clear implication arrows or writing the word therefore to visually show how one line of logic fundamentally leads to the next. They present their information following strict professional conventions.
Let's quickly recap the 3 overarching rules of the ultimate system that basically guarantee top marks. Rule 1. Command word decoding. Always extract exactly what the examiner wants before you write a single number down. Rule 2. Peel framework application. Point, evidence, explanation, link. Structure your algebra so logically that the examiner can effortlessly follow your analytical depth. Rule 3. The time management matrix. Please, don't spend 10 precious minutes trying to randomly guess an answer when setting up the proper substitution takes literally 60 seconds.
I want you to anchor this entire explainer in your mind with these 3 simple words. Deconstruct, solve, evaluate. You deconstruct the terrifying equation into a manageable framework. You solve the simplified quadratic systematically, and you evaluate your final answers to ensure they actually fit the original mathematical context. This is your completely robust problem-solving framework.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.